This lesson is about area of a triangle. We learned in middle school area of a triangle equals 1/2 base times height. In pre-cal level, we will learn the area of a triangle involving included angle. Here is the formula. 1/2 AB sin C and 1/2 BC sin A, or 1/2 AC sin B. Remember, all these angles are included angle. When you are given two sides of a triangle, the angle between these two sides we call included angle. Let's talk about SL formula. For area of a triangle, we got A equals 1/2 AB sin C. Remember, for this C, it's an included angle. And also for this C, there are two possible angles. One is an acute angle. The other is an obtuse angle. So for acute angle, we normally do C1. Obtuse angle is C2. C2 equals 180 degree minus C1. Let's draw a diagram. Suppose the C is the angle in a triangle. Therefore, C will be between 0 to 180 degree. This is 0 degree, this is 180 degree, here's 90 degree. For angle in a triangle between 0 to 90, we call that is an acute angle. For any angle between 90 to 180, we call this is an obtuse angle. As we know, any angle in the first quadrant, we call that the reference angle. We can use pi minus reference angle or 180 degree minus reference angle to get the angle in the second quadrant. Also, I know that all students take calculus. Therefore, when we get area equals 1/2 AB sin C, let's solve for C first. You need to get rid of this 1/2 by doing multiplication both sides by 2. Get rid of this AB by doing divided by AB both sides. So you will get sin C equals 2A/AB. Therefore, for C, you will get inverse sin 2A/AB. C1 will be reference angle. For C2, you will get 180 degree minus C1. Therefore, in a triangle, when you get sin C equals a positive number, remember that there are two values for this angle. One is acute angle, the other is obtuse angle. Let's do some do now. Number 1, suppose theta is an angle in a triangle. That means this is theta between 0 to 180 degree. Sin theta equals 0.5, find theta. For sin theta equals 0.5, that means 1/2, which means reference angle equals 30 degree. In other words, theta 1 equals 30 degree. And then theta 2 equals 180 minus theta 1 equals 150 degree. Because for sin theta equals positive, they will go to first quadrant or second quadrant. For first quadrant angle, that's your reference angle. Second quadrant is 180 minus your reference angle. Let's go to number 2. Suppose theta is an angle in a triangle. So we know theta between 0 to 180 degree. And sin theta equals 0.12. Find theta in degree. We know theta 1 equals inverse sine of 0.12. Put into calculator, you will get 6.892 degree. Make sure when you put into calculator that mode go to degree. Then for theta 2 equals 180 degree minus 6.892 degree, you will get 173.108 degree. For number 3, suppose theta is an angle in a triangle. Theta between 0 degree to 180 degree. And a cosine theta equals 0.5. Find theta. Because for second quadrant cosine is negative, therefore for this theta, it's only go to the first quadrant. That will be 60 degree. Only one solution. Remember, only the sine theta, when theta is an angle in a triangle, there are two possible values for this theta. Now let's go over that formula. I label this is a D, here's E, this is a F. Opposite angle F is a small f, and opposite of this angle D will be small d. Then opposite for this angle E is E. Therefore, area equals 1/2 EF sine D. Remember, D is included angle. Or I can write down 1/2 DF sine E, or equals 1/2 ED sine F. For number 2, I label this is a P, this is a R, here's Q. Therefore, area equals 1/2 PQ sine R, or 1/2 PR sine Q, or 1/2 QR sine P. Can you write down for this triangle XYZ the area formula? Now let's go to some examples. Find the area of a triangle A. We know that two sides, and this is included angle. Therefore, area equals 1/2 times 6.8 times 7, then times sine 97 degree. Make sure when you put into calculator, your mode have to set degree, not radian. Answer will be 23.623 millimeters square. For number C, we need to figure out included angle. As we know, the sum of all angles in a triangle, that's 180. Therefore, for included angle, it will be 180 degree minus 80 degree minus 40 degree. That's 60 degree. Therefore, for area equals 1/2 times 30 times 23 sine 60 degree. Put into calculator, you will get 298.779 centimeters square. Now let's work on extra practice. If you are given included angle in radian, make sure when you put into calculator, set up mode into radian. So we got the area equals 1/2 times 10.2 times 6.4 times sine 2 pi over 3. 28.267 centimeters square. When you have a sine, cosine, tangent, that trig function, when you use calculator, you have to be careful. You need to analyze the given angle is in radian or is in degree, so that you can change the mode into the correct format. For number 4, let's go to B. First of all, we are given two sides. We need, this is a included angle. We know for parallelogram, this angle we can get by doing 180 degree minus 80 degree, that's 100 degree. When we doing 1/2, 7 times 11 times sine 100 degree, we got the area for this triangle. For the whole area of a parallelogram, we just need to multiply by 2. Then we put into calculator, you will get 75.830 millimeters square. When you put all this into calculator, make sure you set up mode into degree. Let's go to number 5. The area of a triangular flag is 429.5 centimeters square. Calculate the size of the obtuse angle ABC. So we're looking for this included angle. We know area equals 1/2 AB sine C. So for sine C, you got 2A over AB. Therefore, we plug in. You will get the 2 times 429.5 over 34 times 34. You will get the sine C equals 0.743. Therefore, for C1 equals inverse sine 0.743. You will get 47.994 degree. For obtuse angle equals 180 degree minus C1. You will get 132.006 degree. That's the correct answer because we are looking for obtuse angle. One more time. When you get sine angle equals positive, if the angle is an angle in a triangle, make sure there are 2 possible solutions. Let's go to number 7. Find the possible value of included angle of a triangle with sides of length 2 cm and 8 cm and area is 15 cm squared. We know that area equals 1/2 AB sin C. And sin C equals 2A over AB. So we plug in. You will get 2 times 15 over 5 times 8. You will get 0.75. Therefore, for C1 equals inverse sine of 0.75. The acute angle C1 equals 48.590 degrees. Therefore, for obtuse angle C2 equals 180 degrees minus C1. You will get 131.410 degrees. Find the shaded area in this figure. First of all, we know that shaded area equals sector area minus triangle area. For sector area, we use 1/2 r squared times theta. Remember, for this theta, that is radian. For triangle area, we use 1/2 AB sin C to figure out. For sector area, we plug in 1/2 times 7 squared times. You need to change 135 degrees into radian. Therefore, we do 135 degrees over 180 times pi. Then we put all this into calculator. You will get 57.727. That's the area for sector. Then for triangle area, you will get this part is 7 millimeter too. So we got 1/2 times 7 times 7 sine 135 degrees. So we put into calculator. Make sure for mode you have to set up into degree. We got 17.324. Then you need to subtract. From 57.727, you will get shaded area equals. Shaded area will be 40.403 millimeters squared. If you are given size of a triangle, we have another formula for area of triangle. That is this formula. For S equals 1/2 A plus B plus C. Let's go to this example. We got the 3 sides of this triangle. Then we need to figure out the area. First of all, we need to figure out this S. That is 1/2. 51 plus 38 plus 45. Put into calculator, you will get 67, that's S. Then we plug into this formula, you will get 67 times 67 minus 51, 67 minus 38, 67 minus 45. Then put into calculator, you will get answer will be 827.004 inch square.